Hello, everyone. I just landed in Berlin yesterday for the very first time in my life, and I've already fallen in love with this city. Sorry. There we go. So my name is Hui Jing, and I go by Jing as well. Now, I really love emojis. And we have 2,666 emojis right now with which to express ourselves, so I'm going to introduce myself with them. So I'm from Malaysia, very proud of that. And I used to play basketball full-time. Basketball actually helped kickstart my web career. So you can ask me about that later, if you're interested. Now, my inordinate love of CSS is what compels me to speak and write about this topic, and it's essentially what put me here on the stage in front of all of you today. I also happen to be a Mozilla Tech Speaker, which is an initiative by Mozilla that supports technical evangelists in regional communities around the world by providing resources and funding. Now, what do you think about when you hear the word typography? It used to be that typography was a bit of a niche subject, something that only artsy, creative types cared about. But these days, it seems that typographic stories have been making their way into mainstream news. We have big brand names like National Geographic and Netflix talking extensively about their font redesigns. The Microsoft font Calibri by Lucas de Groot was a crucial piece of evidence that proved the forgery of financial documents in a Supreme Court case in Pakistan. But what is typography? Now, there are plenty of definitions out there. I personally always refer back to this one by Gerrit Norgay, that typography is writing with prefabricated letters. Now, letters are a type of grapheme, which is the smallest unit of a writing system of any given language. Writing systems are visual representations of verbal communication, a means to record whatever we say in our respective languages for storage and transfer. The world is very diverse when it comes to language and culture, so it's only natural that there are many different writing systems used all over the planet. Now, a majority of the world use writing systems that consist of alphabets. This is just a very small sampling of different alphabets from different languages. Now, the Hebrew alphabet only has 22 letters. The Ukrainian alphabet, slightly larger with 33 letters. That's 7 more letters than the English alphabet, which only has 26. Now, the point I'm trying to make here is that alphabetic writing systems utilize a small set of letters to form all the words a language needs for the purpose of communication. Chinese, a bit different. It's a logographic language. Now, Chinese characters number in the tens of thousands, and each character is a unique glyph that can express meaning on their own or be used in combination with other glyphs. So let's look at a few examples to illustrate this point. The word communication, this is an English word. You'd need 13 letters to spell it. Chinese, we can express the same in 2 characters. We can say 沟通. I'm going to butcher this word, so please excuse me, German speakers. Backpfeifingersig. This is a German word of 18 characters. And in Chinese, we can say something really similar. We can say 千遍. Grünhreifer-Deurechter. This is an Irish word. I may be pronouncing it wrong as well. But again, in Chinese, 2 characters is enough. You can say 摄影. So Chinese is a pretty concise language, if you ask me. And although a large swath of the world reads mostly from left to right, writing systems can go in all directions. Modern-day vertical writing applies to East Asian scripts that utilize Han characters, so languages like Chinese, Japanese, Korean. And these are read from right to left. Mongolian also uses vertical writing, but it's read from left to right. Now, Han characters are sometimes called square characters because each character is composed within a uniform square. So this allows Chinese to be read efficiently, regardless of whether it's typeset vertically or horizontally. Now, Chinese text can be typeset into neat rows and columns. And if you don't understand Chinese, you may not know which direction the text is going. It could be vertical, right to left, or horizontal, top to bottom. Now, the Chinese script is said to have developed independently from Proto-Sinaitic scripts, which were the origins of alphabetic characters. So this is potentially why Indo-European writing systems are inherently different from those of East Asia. As different alphabetic writing systems branched out from the Phoenician alphabet, their letter forms evolved and changed. The appearances of letter forms were often directly influenced by the tools that were used to create them. The earliest letters were sans serif, when writing was done with a hard-read pen. Now, when the transition was made to a square-cut implement, like perhaps a flat-tip brush, the letters developed serifs. Now, in the Middle Ages, when demand for written matter kept growing, scribes and copyists who used quill pens had to develop more efficient styles of writing, so the letter forms evolved yet again. Now, Chinese characters have too evolved greatly since the earliest glyphs were scratched into turtle shells and animal bones as far back as 1600 BCE. So this earliest script was called oracle bone script because the ancient rulers would use them to consult with the various higher powers important questions about things like agriculture, weather, warfare, things that royalty cared about. The key implement of Chinese writing is the brush. Calligraphy was and still is one of the most highly regarded Chinese arts, and the work of famous calligraphers were used as the basis for carving wood blocks used for printing, which was invented in China. But these days, typefaces used for printing Chinese publications can be broadly classified into these four families. We have Songti, Kaiti, Fangsongti, and Heiti, so a bit different from Latin-based scripts. Now, Chinese typefaces are extremely challenging to create, simply due to the volume of glyphs required. Now, the average number of glyphs for a Chinese system font clocks in at around 35,000 glyphs, give or take a few thousand. So this quote is from an article on Quartz that covered the process of creating a Chinese font. It is a pretty interesting read because it goes into how much effort is needed to design and create a Chinese typeface. Now, for a typeface to be viably used as body copy, it will probably need a minimum of 7,000 glyphs if you're using simplified Chinese, or 13,000 glyphs if you're going for traditional Chinese. But that's still a lot of glyphs. Hence, Chinese fonts are almost always designed by teams over periods of years. Now, the web is less than 30 years old. And because it's a completely new medium, it's only natural that people try to reconcile it with something familiar, like print. However, there's an additional degree of separation between the creator and the final output. As such, we cannot have the same set of expectations when it comes to handling the web as a medium. This is a medium where you cannot directly manipulate the canvas, in this case, the viewport of my browser. Instead, what we do is we write code as instructions to the browser to tell them how we want our designs to be rendered. Now, with the release of CSS Grid last year, it seems that we've hit yet another milestone for web design. Now, Jen Simmons, creator of the amazing series Layoutland, you should really subscribe if you haven't, she drew a parallel between the evolution from metal letterpress to photo-based paste-up with this evolution from floats to grid. Modern CSS gives us a wider vocabulary with which to communicate with the browser. So we can leverage these new capabilities that browsers now have for better art direction, more creative layouts, and fresher designs that break out of the cookie-cutter molds we're so used to seeing on the web. Now, as an athlete, I cannot help but draw parallels between my work and my experience with my sport. CSS is a holistic technology in that even though you can use properties in isolation, the full power of CSS shines through when properties are used in combination. So you can treat this talk like a scouting report, where I profile some of the most promising players on team layout, and how they can work really well together to handle certain situations. But really, at the end of the day, like what Jackie mentioned earlier, you have to find a solution that best works for your use case. Now, it was purely by chance that I started exploring vertical layouts on the web. See, I was stuck in a crowded subway train a few years ago, and I was inadvertently peering over the shoulder of the guy standing in front of me, and he was reading a Chinese novel on his phone. So it was typeset horizontally, right? And this was when I first thought to myself, hey, a traditional vertical layout would work really great on a phone. I wonder if this can be done on the web. Turns out it can, and really well too. So these are websites that have won the Tateyoko Web Award, which is given to those who are willing to take up the challenge of ushering in the next generation of web typography for vertical text by designing and utilizing new typesetting standards with modern CSS. Now, some of you may find this hard to believe, but vertical text was supported by Internet Explorer since version 5.5. Oh, yes, they were using a much earlier version of the specification, which originated from SVG. Now, Chrome started supporting vertical text in 2010. This was followed by Safari in 2011, then Opera in 2013, and finally Firefox in 2015. But although vertical writing is native to East Asian languages, that doesn't exclude you from using vertical text simply because you don't design for those languages. If anything, the fact that browsers can now better support vertical text allows us to draw design inspiration from more sources than before. For horizontal-only languages, you wouldn't want to lay out text vertically for long passages, understandably, but there are subtle ways that you can insert vertical text into your designs to add some flavor without compromising the reading experience. An example could be labels for card-based designs, so popular. Or tags for blog posts, cases where text is not critical to understanding the main content. You could even use them for headers, for sections on long scrolling pages. You could perhaps use them for small screen navigation. A lot of possibilities here. But vertical layouts are not a new thing. It's just that the web hadn't reached a level of maturity that could do them well until recently. Take, for example, this is a mixed layout multilingual magazine cover from Japan. This is totally doable on the web today. This poster is by Edward McKnight Corfer, one of Europe's most influential poster artists in the 20s and 30s, and he's already using some vertical text there. Another one by Corfer with some diagonal layout going on there. This one is a vintage cover of Architectural Design magazine with this radial text layout. And then I came across this particular book cover by Coralie Bickford Smith for The Craftsman, and I thought, okay, let's do pencils. Specifically, let's do these vertical pencils with text in them on the web. Now, while preparing for this talk, I got a bit carried away with the sports analogy and ended up being sidetracked by creating CSS trading cards because I have the attention span of a 5-year-old. Anyhow, let's start off with something reasonably familiar. So in this case, CSS transforms. Even though transforms are often used for animation, static transforms can be pretty useful too. My basic strategy was to start off with an unordered list, and each pencil being a list item, then styling each item to look like a pencil, and then lay them out vertically. So the second and third points are actually pretty closely intertwined. So the markup for this is very basic. The additional p tag inside this list item is for styling purposes, because I only have 2 pseudo elements to play with, and that's really not enough for a pure CSS pencil. The key property for the visual effect we see here is borders. Now, the border property, in my opinion, is an underrated CSS property. If you've read Leah Verou's book, CSS Secrets, or watched her really brilliant talk on the humble border radius, you may already know this. But the tips of the pencils are made using the CSS triangles technique, which makes use of the fact that borders meet as diagonals. Now, there are 4 2D transforms that are available to us, and we'll use the rotate transform to get the pencils vertical. Now, the tricky part about using transforms is that you have to keep in mind the transform origin and how the browser deals with transforms to begin with. So transforms bring the element in question into its own layer and takes it out of the normal document flow. So if you're trying to rotate elements that are supposed to be part of a larger layout, which is pretty much all the time, you might end up with unwanted overflows or overlaps. Now, a friend of mine tried to transform an entire website and discovered so many interesting things that it warranted a 20-minute talk at our local CSS meetup. So what other options do we have for vertical layouts? Well, the outcome of my research into typesetting Chinese vertically on the web led me to discover the existence of the writing modes specification. This specification covers all sorts of international writing systems, extending and replacing the Unicode BD and direction features in CSS 2.1. It also introduces a number of rules and properties that are required to properly support vertical text in CSS. So this is what happens to your text when different values of writing mode are applied. Now, the default is horizontal top to bottom. And to change the direction to vertical, we use vertical RL or vertical LR. And when we rotate text, it's not only the lines that change direction. Because you see, each line actually contains individual letters or characters. And they have an orientation as well. For text orientation, the value of this property is initially mixed, because browsers are smart enough to figure out which languages can be typeset both vertically and horizontally, or in one direction only. Chinese characters, for example, will always be displayed upright, while horizontal-only languages like English or German will have their characters rotated when vertical. So the text orientation property lets you control this and make all the characters upright or sideways if that's what you want. Text combined upright is a property that addresses the issues of numerals or abbreviations in vertical text. It allows us to fit them into the width of one character and display them upright. So no browser supports the last one, the digits value, yet. This value allows us to dictate how many digits or letters are acceptable to be squeezed into this little space. So reasonably, the range allowed is between 2 to 4 characters. But for now, we only have the all value. There is no limit. So you could put a really long word, like, I don't know, Beethoven. And the browser will do it. It will squish all those letters into that single character space. Probably not something you want, but you could always try it out. So back to pencils. We'll keep the same strategy as before, except that the layout and visual styles are essentially done together, and you'll see why in a bit. No change to the markup. Here, we apply writing mode first, because presently, we still rely heavily on the physical directions of left, right, top, bottom when it comes to styling elements. Hence, all the borders that I used previously, they have to be recalibrated, because it's not as straightforward as taking the styling from the transforms use case and slap on vertical RL and call it a day. No. If you compare the code for this, and it's a bit lengthy, you'll notice that even though the words are rotated and flowing from right to left, the direction of margins and paddings still adhere to our upright perspective. So, for example, padding on the left of my pencil text, I have to apply it using padding top. And this sort of confuses me a lot. But luckily, we have an up-and-coming new player on Team Layout, the CSS logical properties. What it does is it uses logical properties like block start and block end, and inline start and inline end, which are relative to the block flow of the page, allowing us to use the same code regardless of writing mode. I highly suggest reading Rachel Andrews' in-depth article on CSS on Smashing Magazine to gain a better understanding of this relatively new spec. In fact, the first public working draft of the specification was published in December of last year, and I'm really eager to see it developed and more widely implemented. Now, we can't talk about layout without talking about Flexbox. And Flexbox is definitely an all-star player on Team Layout. Now, if you try to print out the specification, it's about 87 pages long. And there's a very good reason for that, because it defines a new layout mode designed for laying out complex applications and web pages. It's probably the first property specifically designed to do layout on the web. So let's have more pencils, many, many more pencils. And I want them to be a mixture of vertical and horizontal pencils. So this is becoming a larger scale layout situation. And Flexbox is capable of handling this. It's very versatile like that. You can use it for small components or a bigger scale layout. So the markup is similar to previous examples, just multiplied lots of times. Now, these pencils are a mix of vertical and horizontal with different colors, so you can see which way they're being laid out. Now, the cool thing about Flexbox is that it can do space distribution and content alignment like nothing we've seen before. Flex children can be laid out in any flow direction, leftward, rightward, downwards, or even upwards, if that's what you want. Display order can be reversed or rearranged, although this does have accessibility implications and should be used with caution. But items within the Flex container are laid out like a long daisy chain. But even if they wrap around, there's actually no relationship between the rows and columns. It's just one really long row or one really long column that wrapped around itself. So a property that controls the flow direction is aptly named flex direction. And with this, we can actually reorder the flow of content. So the default value is row. But if I want to reverse it, I can say row reverse, and you can see, based on the colors, that it has changed the way it's flowing. And we have other options as well. We can do flex direction column, and you can see it's now this way, going downward. Column reverse makes it go upward. So you're not limited to just left and right, which is actually the title of my talk. Now, again, I want to emphasize that this merely modifies the visual order and not the source order of the flex items. Screen readers and keyboard control will still respect source order. Now, if Flexbox is an all-star, Grid is shaping up to be a Hall of Fame level legend. Because Grid lets us do a lot of things that were previously either impossible or highly untenable. Now, I never talk about Grid without quoting Rachel Andrews, so here's a good one. Grid works from the container in, while other layout methods start with the item. So think about how we've done layout in a pre-Grid era. Say we wanted to create a very simple 3-column uniform grid. One approach for creating such a layout is with the inline-block. So for this, you would set the display of your items to inline-block and give them all a width of 1/3 of the container. It's almost the same if you use floats, because you also need to set a width on each item. If you use Flexbox, to ensure that the items line up in 3 columns, you have to make sure that the flex basis is also 1/3 of the container. The properties we're applying always go on the item. So for all 3 of the techniques I've just described, there is no grid. It just looks that way, because we force the items to line up with each other. But with Grid, the grid is real. We define its rows and columns, then we place items on the grid wherever we want to. We are freed from the limitation of elements having to line up next to each other all the time. This means that our layouts can now be canonically non-sequential. We don't have to mess around with absolute positioning or spacer divs or any of those other workarounds that we used to do for vertical spacing anymore. Like here, I have a 6x6 grid with 6 grid items arbitrarily placed anywhere. And Grid makes it really simple and intuitive to have vertical white space in our designs. So you essentially just define which row and which column you want your item to be. It's just coordinates. So if you change the row, I can just move that soccer ball down the grid. So it's really intuitive to have vertical white space in our designs with CSS Grid. And like I mentioned, there's a lot of great graphic design that we can draw inspiration from. For example, this is a page from Laszlo Molinage's book, Mallory Photography Film, butchering the pronunciation brilliantly, you might say. This is a striking design with bold black borders and content aligned in different configurations. And if we want such a design on the web, some teamwork will need to be involved. The code here is abridged to show mainly the layout, but even the gear and arrows can be made with pure CSS. It's a box shadow trick. But in order to align the internal content of each grid child without disrupting the rendering of those thick black borders, we'll need to make each grid child a flex parent. So by default, the value of a grid item's alignment is stretch, where it fills up the entire space of the grid cell. However, once you apply an alignment onto the grid item's contents, it will shrink to fit the content. Now, making each grid item a flex container allows us to use box alignment properties to adjust the position of the grid item's content while keeping the borders at the edge of the grid. Another thing that Grid makes a lot easier is overlap. We could have achieved an overlap effect with absolute positioning, but removing an element from the document flow usually brings about a lot of unwanted consequences. With grid placement, overlap is easily achieved without disrupting the rest of the layout at all. So this is from another vintage publication, English painter Charles Hayter's A New Practical Treatise on 3 Primitive Colors. Totally doable on the web. Again, the code is abridged, but placement is a matter of defining which row and column you'd like your element to appear in, and how many grid cells you'd like it to take up. It's perfectly acceptable to have multiple elements occupy the same space on your grid. So this demo was also an excuse to play with blend modes. CSS blend modes actually works the same way as in Photoshop, and I learned from Leah Veru last week that it was Adobe who proposed the specification for it. Now, this particular poster for Braun is by German graphic designer and photographer Wolfgang Schmittel. It is a rather griddable design, so no surprises here that such a design can be done on the web with CSS Grid. But when we take into account how dynamic the web is, we are designing for a medium whereby we have absolutely no control over how our designs will be viewed, things get a little bit more interesting. And it's probably a better idea to consider aspect ratios over absolute dimensions when it comes to designing web layouts. And the aspect ratio media query lets us do that natively. Even though the most common media query we use is width, there are 13 media features that are available for use as conditions, including height and orientation. Somehow we're just not seeing them being used very often on the web at the moment. Aspect ratio media queries are especially useful for designs that use viewport units. But there's no limit on how you wish to combine multiple media queries to make your design fully adaptable. Now, an often raised concern when it comes to using the newer CSS features, especially those for layout, is browser support. Because, nobody wants their site to look broken. That's legit. So here is where feature queries come in. And Oliver, who's coming up after me, is going to go into a lot more detail, so I'm just doing a brief preview to warm you up for his talk. This is how a feature query looks like. The conditional checks if the browser supports a particular property or not. If it doesn't, the entire block within the @supports rule is ignored. This means that we start off with a basic layout that works everywhere. Then we layer on styles based on the features we want to use. By organizing our code in this manner, the browsers that do not support feature queries or the specified property will still get styled. And those that do get a different look. So we're making use of the C in CSS. So this image was the header for a CSS Tricks article, and it caught my eye. Because it was diagonal and really nice looking. It looks almost exactly the same when recreated in HTML and CSS. Almost. With feature queries, you can do quite a lot of things. For example, you can display a message informing users that a feature is not supported with pseudo elements, and having a fallback. For this particular example, it's just an image for IE11. But more often, the feature query will contain code that acts as an enhancement to a design that works in all browsers. And there's nothing stopping you from using feature queries and media queries in combination to cater for different browsers on different devices. With feature queries, we don't have to revisit our code base to rewrite things when a browser gets updated, because the code is not browser-specific. It's feature-specific. And once a feature gets shipped, your design will be updated automatically. This example makes use of a combination of feature queries for both grid and CSS shapes. So if you're on a legacy browser, you'll get a simpler design, but everything is styled on the very left. For now, Firefox users, in the middle, they don't get to see the CSS shapes yet. But once they do, the layout will automatically look like what Chrome users see at the moment, on the right. It used to be that a new feature or bug fix would take a long time to ship. And that was true in the earlier days, where browsers were updated maybe 6 months, every 6 months. But these days, the upgrade cycle has shortened immensely. This is probably not the best data visualization you've ever seen, but the point I'm trying to make here is that browsers are being updated fast and furious these days. My favorite example to talk about is the release of CSS Grid. Now, most major browsers shipped it in March last year. By October, 75% of users around the world were using a browser that supported Grid. Today, that number, 87%. How amazing is that? It's so much easier to get enthusiastic about new CSS features these days because they ship and become more widely supported so much quicker now. And the same goes for bug fixes. Every major browser engine has a pretty open process for raising bugs, and raising bugs for a particular feature sends a signal to browser vendors that developers want to use this feature. This encourages them to prioritize related bug fixes. It's a win for everyone. By taking the time to submit a bug report, you gain karma points, you get your bugs fixed, and you make the web better for all of us. So that's it for me. And I just wanted to round off by saying that you don't need to use any of these techniques or properties I covered if they don't fit your use cases today. But know that when the time comes, they'll all be right here waiting for you. Thank you all for your kind attention.